Hey there, fellow data enthusiasts and ML aficionados. Welcome back to another LinkedIn Live session. Kamesh here, lead developer advocate at Snowflake, tuning live from Bangalore. Boy, do we have another exciting thing for you today. We are about to dive a game changer for ML workflows, our brand new container runtime for Snowflake notebooks. It's now public preview across all AWS commercial regions, and trust me, it's going to revolutionize how you build and scale your ML models. What's cool about it? We have packaged all popular libraries, Python libraries, and frameworks. It's like your favorite ML playground right out of the box. Easily extend your environment with packages from PyPy and Hugging Face. Your toolkit, your rules. Our new APIs auto-magically parallelize data loading and model training. We are talking 3 to 7x faster execution. Feel the need for speed. Efficiently scale your ML workflows without breaking sweat. Handling big data like a pro. But wait, there's more. We got a killer demo lined up to show to you. This bad boy in action. And joining us today is Vinay. He's our product manager for Snowflake's ML platform, focusing on making production grade ML development a breeze with these souped up notebooks. Vinay has years of experience on AI/ML platform space across companies of all sizes, so he knows a thing or two about what developers like you need. So, are you ready to the future of ML development on Snowflake? Let's dive in and explore how this container runtime can take your projects to the next level. Get ready to have your mind blown. Over to you, Vinay. Show what this baby can do.
Hey everyone, nice to meet you all. Good morning, good afternoon, good evening, wherever you are. So, my name is Vinay. I'm a product manager here at Snowflake. And today, like Kamesh just mentioned, we have an exciting content and demo for you. So, we're going to be talking about end-to-end ML workflows with Snowflake notebooks with the container runtime. And we'll dive into each of these in more detail. So, we'll talk about what Snowflake notebooks are. We'll take a peek under the hood for what we mean by container runtime. We'll look at a few key features and a few benefits. And the exciting part, we can go through the demo and any questions or answers you have for questions we have for us, we're happy to answer. Great. So first things first, what is a Snowflake notebook? So it's your familiar notebook experience. It gives you an interactive, unified, cell-based development experience where you can do Python, SQL, Markdown, visualization, and all sorts of operationalization capabilities, all within the familiar Snowflake UI and Snowflake experience. It's it's significantly simplifies your ability to connect the data because the data just is in Snowflake already. Um, but with scale out data engineering, you can run analytics, all of this on top of your Snowflake data with very, very minimal configuration needed. It's super easy to use, as you can see in this quick GIF, and we'll also look at the demo. You just have to point your mouse to the Snowsite UI, import an existing notebook that you have, or start with a new one. You also have the ability to connect to Git repositories and pull from there. And also, if you're looking to operationalize your notebook, we have the way to schedule these notebooks and run them on that schedule. So great, that's the Snowflake notebooks. But we're here to talk to you about notebooks on container runtime. So what is the container runtime? So it is a fully managed environment where you have access not just to CPUs, but also to GPUs, all within the convenience of the notebook. But in addition to that, you've got extremely efficient and optimized data loading via efficient data connector APIs. You have distributed training, which gives you the scale that Kamesh mentioned. And you have integrated model governance with automatic lineage capture, integration to the model registry, so you can then serve your models at scale. What the notebook on container experience gives you is a flexibility, so you can run your ML workloads at scale without any data movement. But it also gives you the ability to use your open source packages that you're comfortable with. You can bring in your notebook exactly the way it is and not have to worry about any package management concerns. Because with the pre-installed ML package image that we have, most of your popular open source packages are covered, but you always have the option of extending that with convenient pip installs. So again, using it is really simple. It's the same notebook experience. You just click on run on container, pick the GPU or CPU pool you want, and you can get going. So let's give you a little bit more intro and details around what the container runtime is. So one, given its open nature, you can bring in models from anywhere. You can work with open source popular hubs, for example, bring in a model from Hugging Face and just use it right in the notebook. But the image itself, the runtime image itself, comes pre-built with these latest ML packages, all the popular ones that you can imagine, plus the ability to extend it if your organization needs you to use a particular version. But at the same time, this entire runtime stack also comes with built-in scalability and optimization. When you're running really large-scale ML, you can be rest assured that you're taken care of. With distributed training APIs, we're extending popular open source frameworks like XGBoost, LightGMU, and PyTorch. And with a simple change to the interface, you're able to distribute their workloads across multiple GPUs and, of course, also multiple CPUs. And data loading has always been a concern. So with new data connector APIs, you can easily, efficiently pull in data using a parallel data ingestion framework that is powered by a Ray cluster, which is fully managed and is abstracted away in the container runtime. Now, all of this runs over our Snowpark container services. So you have access to CPU or GPU pools, and that gives you the compute flexibility based on your task, your scale of your task. Great. So having said that, we can dive into a demo. Now, in this demo, I will first introduce to you how the notebook experiences looks like how you create a notebook, and then we can look at an example of a notebook that uses the container runtime. So it's really easy to create a notebook. Like I said, you can start a new notebook, or you can import a notebook from your local file system, and or also connect it through a Git repository. So in this case, let's start with a notebook that I'm uploading. It's really simple. I just have to pick a few configurations, and here I pick container, run on container, which gives me the CPU and GPU pools and gives me all of those benefits we just spoke about. It's as simple as picking a runtime. So if I know I'm going to be using GPUs and I want to be using a deep learning framework, and this runtime image comes again with GPU specific packages that gives me that scale and gives me that flexibility and compute power I need. And here it's administratively set up. All I need to do is click the appropriate GPU pool. These are all named references to GPU pools. You can look up our documentation that tells you what type of GPU you have, how many of these GPUs, and so on. And you'll see in a bit how we can even do that on our own. So that's it. It's as easy as selecting a few things, and you can get going with a really powerful notebook and with the deep uh, the scale out processing capability that comes with this. So in this example, we have a notebook already set up for you, and we'll quickly walk through some of the highlights. So as we said, we are going to be using the container runtime to show you a really scaled out ML workload. Now, first things first, I just want to make sure all of my open source packages are in place. I already know there's a lot of packages that it comes with. So a quick pip freeze command tells me everything I have. But in addition, I can easily bring in something else. So in this case, I want to work with an OpenCV model. It's as easy as pip installing it, and I can get going. Now, I do want to make sure I have the right GPUs. So yes, of course, you can reference the named GPU pool, but here you have easy access to popular CUDA libraries. So if you try to set up GPUs yourself, I'm sure a lot of you have run into the complexities of packaging up CUDA, making sure the dependencies are in place. But what we have for you is everything out of the box. You don't have to worry about doing any of that setup, and it's easy to go. So here I know I've got 4 GPUs. And of course, I can, of course, always run a hashbang NVIDIA SMI command to get more info about the GPUs and appropriately use it in an open source package or the Snowflake APIs, as you see. So great. So prerequisites out of the way. I have the pip installs in place. I have the resources I need. What we're dealing with here is a pretty large data set. It's 120,000 images, hundreds of gigabytes. So you can imagine the scale that you need to be able to run this notebook. Now, in this case, what we're doing is a really quick data transformation where we've encoded these images, and you have a few labels here. So the goal of this notebook is to be able to create a defect detection model. So that's really popular in manufacturing sectors. You want to be able to process images and detect and classify defects. So here what we're working with is each image with a category of a defect as a label, and appropriate bounding boxes to point to where in that image that defect lies. So this is just a snippet of the data, and we'll walk through how the power of this notebook enables you to run this at scale. So here's again a quick glimpse at what one of those labeled images look like, and we'll see later on the inference in action. So great, let's dive right into the training here. And here's where the meat of the and the processing part of the container runtime comes to play. Now, in this case, I know I want to use PyTorch. PyTorch is great at leveraging GPUs, but it can only work well when you're using a single GPU. If I have to distribute it across multiple GPUs, which in this case I do need to do with a 120,000 image data set, it's going to take a long time and may not even complete. So if I want to split this across, here in this case, 4 GPUs, if I have to use open source PyTorch myself, it's a lot of work to orchestrate that. I need to have the right distribution. I need to have the right processes set up. I need to evenly distribute the data. I need to make sure it's fault tolerant. All of that is really hard to do each time I work with a notebook. So what we're doing here in the container runtime is you simply call the training function, which is your standard open source training function. You can pull in PyTorch training functions from anywhere. And simply point to our API, which automatically distributes it across the GPUs. So our server and container runtime service manage that orchestration for you. It calls the training function, it automatically distributes the data to each of these processes, and it orchestrates it, synchronizes it. So the model, at the end of the day, you have a model that's ready to go. Now, it's as simple as this. So like I said, this is a training function that you can pull in from anywhere. This is a standard PyTorch sequence. You're going through the standard forward and backward passes, the optimizer step, and so on. Again, like I said, standard open source stuff. But where the power comes in is in just these couple of simple API calls. You set up a sharded data connector, which is a new API that we provide, which loads a really large Snowflake table and can distribute it across multiple shards. So each GPU has its own data section, and data chunk to work with. And using our PyTorch distributed framework, that same training function, which is an open source training function, can easily be scaled to multiple GPUs with a really simple config. You just hit run, and a few minutes pass, and you've got a model ready to go. That's it. It was as simple as that. Now, we also did the same test on that 120,000 image data set, and what would normally take hours to complete took about 30 minutes. And again, this is on a 4 GPU, A10 GPU instance. A larger GPU, more number of GPUs, we've seen this linearly scale, so you can imagine this become even quicker. Now, the benefits here, the more frequently I'm able to train, the quicker I get to a model that I can evaluate, the more such experiments I can run, and the more accurate I can get. So in a given time frame, the accuracy that you can get via this experience is a lot higher. So that's the benefit of having this large scale training capability. Now, my job doesn't end here. I still need to make sure this is deployed. So with our integration with the Snowflake model registry, you can easily log a model, and the log model can then be deployed or evaluated against. So here in this case, we're running a simple run command on the log model, and you can see here that we were able to generate an inference. So this inference in this case has identified 4 defects with a pretty high confidence score. So this gives me confidence that the model is in a good place and I can deploy this further. Now, we have conveniently a deployment service involved. So you can just simply call over the same model reference a create service invocation, which deploys this model as a service where you can run batch inference at scale, and you can also run point-by-point inference. Now, let's look at one of this in action. So we've built a simple application where all you do is pass in an image, and you can run a defect detection. So in this case, we'll take a look at one of these images. You can see that this is a raw image. There's no defects called out. And I can simply click on run defect detection. And this is, and the background, loading up that model, running that model training, model inference service, and is going to give you the defect identified. So this could take a few seconds, and I already have run that ahead of time. And here I can see there's a bunch of defects identified with this. And you can imagine doing this in real time. You can imagine this in an industrial setting where you want to classify defects as they come in, and realize business value from this sort of machine learning workflow. All right. So you've seen end to end how we've been able to utilize the power of the container runtime to train a really large data set really quickly, iterate quickly to be able to get to a high quality, high accuracy model, and take this further. You can deploy this to the model registry, manage the models there, and then even deploy this to an endpoint where we built an app. So glad, hope you enjoyed this demo. Kamesh, it's over to you now.
Hey, thank you, Vinay. I think that was a wonderful explanation of the whole stuff. I know there's lots and lots we're going on that. Like I think probably like we can. It will be great if we can have those resources shared with the developers so that they can go back and try the stuff. So let's wait. I think probably like I'll ask the audience to start posting their questions to Vinay. What are the questions that they have? While they are doing that, I have a few questions going through the stuff. Probably I'll start with those things, and we can take the questions from the audience like once we are able to get that in. My first question was like I was seeing you on the notebooks. You're doing those pip installs and all these stuffs like to add some libraries or packages that you basically want to add to a model. Is that only thing we can do with those container image? In case, let's imagine that I want to add a OS package. Is that doable, or it's not doable?
Yes, this is a fully flexible notebook environment. This is not exclusively for ML. What we've done is specialize it for ML. So there's a lot of ML specific APIs that we've built in that help you scale ML. But it's a notebook which is fully open. You can use it for anything. We've seen customers using it for just simple analytics operations. You've seen customers using it just to run their open source Python code that they've been able to import into Snowflake. So it's flexible, like I said, and it's open for most open source use cases.
Okay. My next question would be is like, if we have this model, I mean, sorry, the image, the container image that we are using right now, like which is I understand it should be from our Snowflake hub of the container hub. So is this usable by developers on their laptops? Meaning to say, okay, I can download this container image, Docker pull, and then start a dev container on my VS Code, and then connect to this and start doing stuff, right? It's kind of like starting to do the typical DevOps principles of starting from day one on the same environment where my production is also going to go. Is that something doable?
So great question. So as of today, that image is accessible through our notebooks. So that's the first place where we've exposed it. But we are working actively to also make sure this is available for you to be able to work from, experiment on in your own notebook, and then bring it into Snowflake to be able to scale it out. But as of today, because it's public preview in the notebook, that's the one interface for you to access it. And we are working on making this available outside as well.
Okay. So I think that has a little follow-up question. I heard like we can bring it back in. So does that mean, for example, like let's say I start with a notebook, I don't have a bunch of packages which I want to install. I start installing as part of my notebook steps, which is going to be the similar step that I'm going to repeat, right? Traditionally, in a container world, we basically make those steps already available in the image and start using the new version of the image. Is this something is going to come up in future saying, okay, I can also update the image, push it back, and then get it back again, or something like that? Is something in roadmap?
That is something we've heard a lot coming from our customers, and I can imagine a lot of use cases. Like, for instance, you want to make sure you're compatible with your own organization's policies. You want to make sure there is a blessed image that you want to work with. So these are all critical use cases that we've heard, and we are definitely working towards making that available. And that will take the form that you said. Like, I have the base image, I can add my own packages and create a new version of the image and be able to use that going forward. So it's not yet available. That's something that we're working on. So it's on our roadmap.
Okay, I think I'll just have one more last question, more towards like the CVE side of things, right? Like for example, like when you get the images, let's say the user like he has a pip install of the a particular package, and then we identify that package as a bunch of CVEs down the lane, right? So are we kind of like having some plans? Like, okay, stop, like this has CVEs, so we will not install it some kind, because like Snowflake, like we're known for our governance and security stuff, so we want to make sure the environment is not becoming unstable with CVEs and other stuff, right? Is this something your team has thought about, like, hey, can we do this as well, like, so that like it's we giving the most best safer environment for the for the developers. Maybe it might be today, maybe down the line as we are updating the images, right? Yeah.
Yeah, 100%. That's top of mind for us. Vulnerability detection, vulnerability scans are top of mind for us. We understand that you want to be at the cutting edge and use open source packages as they come out. We don't want to stall innovation that way, but at the same time, there is also the need to be able to make sure that this is safe and secure environment. So we also have with notebooks the ability to also use a Anaconda channel. That's through our other notebook experience, which
Okay.
comes with some of these guarantees that you get.
Okay, the same Anaconda channel that we use from other places is going to be the same one that we also use from the notebooks,
So
or
for
it's
the
going to be
container
different?
runtime, you have an open source equivalent of that. It's Condaforge. So that's something that you can work with.
Okay.
And
Awesome. I think thanks so much for those questions. I think I might keep asking lots of questions, but I want to see if there is interesting questions from the audience, to see if we can take few while you have few more minutes left to before we close. I don't think so that we have any questions coming from the audience yet. I think probably I think that's pretty much I have. Vinay, if you have anything that you want to let the developers know, you can just let it know, and then like we can say goodbye to them wherever they are.
yeah, sure. I mean, I'm sure the references are going to be shared with you. We have our blog outlining all of these benefits I just spoke to you about. But what's more interesting, there is an engineering specific blog that we're also releasing, which goes pretty deep under the hood. It talks about the performance benefits. It shows you a benchmark for how we're comparing with like the open source variants, for instance. And there are a lot of resources. So we've got quick start guides. We've got um, getting started guides, but we also have advanced use cases where we're showing how you train XGBoost at scale, or how you train PyTorch and like GPM at scale. So there's a lot of interesting resources we're putting out. We really encourage you to go through them and look to get started, and hope you're successful.
Yeah, thank you so much. When I think just I want to stress one more thing before we say goodbye to you all. It's like as we are doing at Snowflake, we are making GenAI easy, efficient, and trusted. This is one classic example of how we can get started building your stuff without worrying about my GPU, CPUs, and other infrastructure pieces that I've been to. What I've just go into notebooks and start doing the stuff that I want to do, and we're going to make it even more better and better down the lane. I hope keep watching on that, keep checking on our YouTube channels, get it subscribed to get the latest ones. And thank you so much, Vinay, and thank you everyone for joining us from wherever you are. Looking forward to talking to you on another episode of LinkedIn Live down the lane. Good night and good day, good evening, wherever you are. Bye bye.